There have been hundreds of investigations performed on board the space station, and while the astronauts are living there, it's part of their job to ensure that researchers on the ground get the scientific results on the experiments that many of them have worked years on. Lori Meggs is joining us now from Marshall Space Flight Center, where those experiments, or payloads as they're called, are planned. Lori?
It's kind of mind-boggling when you think about all the things that go into training for one expedition. Add on top of that all of the science experiments these astronauts have to learn how to perform. We recently caught up with Expedition 3435 astronaut Tom Marshburn while he was here at Marshall speaking with researchers about payloads, processes, and procedures. We're up to nearly 300 per expedition, 300 experiments, payloads. How do you keep that all straight?
Really, it's the job of the ground control team, and they do a wonderful job of keeping that straight. Every 5 minutes on board is blocked out for an astronaut, so we do as directed. We go from payload to payload. The challenge in being an astronaut is to switch gears in between payloads, to remember what's special about this one based on work we had done maybe the day before or so, and otherwise we just have to rely on the procedures.
What's helpful to you in procedures? I know you came to this meeting to talk about some of the things that might help another crew member out.
The things that are most helpful about it, since the astronauts are a checklist-driven group of people, we survive and train on our spacecraft launching and landing using checklists. So we're very used to that. We find they're very efficient and time efficient and often very accurate. So we rely on those. To the extent a procedure can match a checklist, we love that. Now, if narration is required, so hopefully developers can keep the narration short in a procedure, and if not, then a video is a wonderful way to get through those tricky, sticky parts of payloads procedures.
What stood out to you? What was your favorite to work on?
One of my favorites was the capillary flow experiment. Part of that's because very visual. Astronauts, without being specialists in the area, can make visual observations that are meaningful to the ground team. And also we get to talk to the principal investigators and the developers on the ground directly. So we can all marvel at the same time at what we're seeing. We can all make observations and contribute. A lot of back and forth is wonderful. To the extent that we can talk to the lead scientists and the principal investigators, that's when it's the most fun and I think the most productive. I love talking to them, and then when we come back from flight, any chance we get to have a personal contact, say thank you, and even talk more about their experiment, we love that chance.
Now, a lot of them you're performing the experiment, but a lot of them are being performed on you. What's that like, to be on the other side, to be the subject?
Yep, so humans are definitely subjects in the experiments. It ranges quite a bit in terms of the impact of our day-to-day life. We understand that one of the reasons we're there is to learn about being in space, so we take the hit in that regard. Sometimes you got stuff stuck all over your chest, EKG electrodes. Sometimes you're doing a lot of blood draws, collecting your own urine, which in 0G can be a challenge. So it does impact your day quite a bit. Impacts the way you eat, the way you go to the bathroom, all of that. But you know how important this is because there's no other way to get this information unless it's done on a person, and I'm frankly very happy to be the person that's in space doing it.
Why did you want to go to space?
I've cut my teeth on the Apollo program, seeing what had happened with going to the moon and figuring out how to go to the moon, and just an intense curiosity and desire my whole life to know what's out there beyond the atmosphere and to understand better what's going on, how people can live in space for as long as possible. So that human element of space flight is what attracted me, so I became a doctor and then a flight surgeon, and I was lucky enough to get a chance to experience it myself.
If there's one thing you could tell people here on Earth of why the space station is so important, what would you tell them?
It's actually, the space station is important on several levels. Number one, we are finding out things that are groundbreaking for physiology and for physics. You simply cannot do a lot of this, or any of it really, on Earth. Taking advantage of the radiation environment, the weightlessness, the vacuum. The Earth-based platform, Earth viewing platform you get, the astronomy platform you get from the space station has been opened up a lot of possibilities for not only launching many satellites, but also getting continual real-time observations of our universe, like the looking for dark matter. You can't do that anywhere else except a space station. For me, though, the prime benefit comes from nations coming together for one of the first times in history to to work together, not for our survival, not for our self-defense, not even for commercial reasons, but to do it because we want to know what's going on out there. And I think it's a huge step forward in human evolution, really.
What's next for you? You going back?
Would love to go back into space. Don't know if it's going to happen. There's a lot of very good, smart people that haven't gone yet that need to go. So to the extent that I can help them go and maybe help lead a group, if ever that opportunity arises in any capacity, I would love to go.
A little jealous of that Scott Kelly getting to stay for a year?
Stay for a year. He's going to be good as being the first to break the barrier there. It's been done before, and yeah, we're all a little jealous that he's getting to do that.
We're all jealous. Now taking a live look into the Payload Operations Integration Center. A busy day for the team here led by Craig Cruzen today. They've been supporting the astronauts as they work on the FIR ACE and deliver the first sample in there for a 72-hour run. They've also helped perform the annual checkout of the microgravity science glove box, and so good news, it's good to go for another year. Everything checked out fine. And the Marshall Pros, the payload rack officers, they've been loading updates to the ELCs. Those are the outside payloads for new capabilities for new experiments. And that'll do it for us here at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.